Article 110.14c of the National Electrical Code addresses the connection of dissimilar metals, specifically aluminum and copper conductors. The presence of aluminum wiring connected to copper pigtails at receptacles within a dwelling without the application of a listed antioxidant compound constitutes a code violation. Aluminum and copper possess differing electrochemical properties. When these two metals are directly connected, a phenomenon known as galvanic corrosion can occur. This corrosion arises from the electrochemical reaction between the two metals in the presence of an electrolyte, such as moisture. Aluminum is more anodic than copper, meaning it has a greater tendency to lose electrons. In the presence of moisture, aluminum atoms will readily give up electrons to the copper atoms, resulting in the oxidation, or corrosion, of the aluminum. This corrosion process leads to the formation of aluminum oxide, a non-conductive substance that increases the resistance at the connection point. Over time, this increased resistance generates heat, further accelerating the corrosion process and potentially leading to a thermal runaway situation. The heat generated can degrade the insulation of the wires, creating a fire hazard. An antioxidant compound, also known as joint compound, serves to mitigate the effects of galvanic corrosion. This compound is typically a grease-like substance containing zinc particles or other conductive fillers. When applied to the aluminum conductor before making the connection to copper, the antioxidant compound performs several critical functions. Firstly, it creates a barrier that inhibits moisture from reaching the aluminum-copper interface, thereby reducing the electrolytic action that drives corrosion. Secondly, the conductive particles within the compound help to maintain a good electrical connection, even if some corrosion does occur. The antioxidant compound fills in microscopic gaps and irregularities in the surfaces of the conductors, increasing the contact area and reducing the overall resistance of the connection. Thirdly, the compound helps to stabilize the aluminum oxide layer that forms on the surface of the aluminum. While aluminum oxide is non-conductive, the antioxidant compound prevents it from flaking off and further increasing the resistance of the connection. The absence of an antioxidant compound in the described scenario means that the aluminum-copper connections are vulnerable to corrosion, overheating, and potential failure. The increased resistance at the connections can also lead to voltage drops on the circuit, affecting the performance of connected appliances and devices. It is crucial to rectify this situation by disconnecting the aluminum and copper conductors, cleaning the aluminum wires to remove any existing corrosion, applying a listed antioxidant compound, and re-establishing the connections. When making these connections, it is also recommended to use wire connectors specifically designed for aluminum to copper connections. These connectors are typically marked with the letters ALCU or CUAL to indicate their suitability for use with dissimilar metals. These connectors incorporate features that further minimize the risk of corrosion, such as pressure plates that distribute the contact force evenly across the conductors and insulated bodies that prevent moisture from reaching the connection point. Furthermore, the National Electrical Code recommends the use of a torque screwdriver when tightening wire connectors. Proper torque is essential to ensure a secure and reliable connection. Under-tightening can result in a loose connection, which increases resistance and generates heat. Over-tightening can damage the conductors or the connector itself, also leading to a potential failure. A torque screwdriver allows for precise control over the tightening force, ensuring that the connector is tightened to the manufacturer's specifications. The specific torque value will vary depending on the size and type of connector, so it is important to consult the manufacturer's instructions. In addition to addressing the immediate issue of the missing antioxidant compound, it is also prudent to conduct a thorough inspection of the entire electrical system to identify any other potential problems related to the aluminum wiring. Aluminum wiring was commonly used in residential construction during the 1960s and 1970s, but it has since been found to pose a higher risk of fire than copper wiring. Over time, aluminum wiring can loosen at connections, leading to overheating and potential fires. There are several methods for mitigating the risks associated with aluminum wiring. Firstly, the entire aluminum wiring system can be replaced with copper wiring. This is the most effective solution, but it can also be the most expensive. Secondly, The aluminum wiring can be pigtailed to copper wiring at all connection points using a listed anti-oxidant compound and connectors specifically designed for aluminum to copper connections. This method involves connecting a short length of copper wire to the existing aluminum wire and then connecting the copper pigtail to the receptacle, switch, or other device. Thirdly, the existing aluminum wiring can be connected to specially designed receptacles and switches that are rated for use with aluminum wiring. These devices incorporate features that minimize the risk of corrosion and loosening at the connection points. When inspecting an aluminum wiring system, it is important to look for signs of overheating such as discolored or melted insulation, burnt or blackened connections, and the smell of electrical burning. If any of these signs are present, it is essential to have the system evaluated by a qualified electrician immediately. The electrician can assess the extent of the damage and recommend the appropriate course of action. In summary, the absence of an anti-oxidant compound at the aluminum-copper connections constitutes a code violation and poses a significant safety risk. Corrective measures should be taken immediately to mitigate the risk of corrosion, overheating, and potential fires. A thorough inspection of the entire electrical system is also recommended to identify any other potential problems related to the aluminum wiring. The use of proper materials, techniques, and tools is essential to ensure a safe and reliable electrical system. It is always best to consult with a qualified electrician when working with electrical wiring. An electrician has the knowledge, skills, and experience to properly assess the situation and recommend the appropriate solutions. Attempting to perform electrical work without the necessary training and experience can be dangerous and can potentially lead to serious injury or death. Also, homeowners should be aware of the specific requirements and regulations in their local jurisdiction. Electrical codes and regulations can vary from place to place, so it is important to ensure that all work is performed in accordance with the applicable standards. Furthermore, it is important to keep accurate records of all electrical work that is performed, including the date of the work, the materials used, and the name of the electrician who performed the work. These records can be helpful for future inspections or repairs. Regular maintenance and inspections are also essential to ensure the continued safety and reliability of the electrical system. Homeowners should periodically check for signs of damage or wear, such as cracked or frayed wires, loose connections, and damaged receptacles or switches. Any problems should be addressed promptly by a qualified electrician. By following these guidelines, homeowners can help to ensure the safety of their homes and families. It is important to remember that electricity can be dangerous, and it should always be treated with respect. If you are unsure about any aspect of your electrical system, it is always best to consult with a qualified electrician. This may include hiring a certified electrical inspector to evaluate the home's electrical systems. A comprehensive inspection can uncover hidden dangers and code violations. The inspector will generate a detailed report outlining any issues and recommend corrective actions. Prioritize addressing any immediate safety hazards identified in the inspection report. This could include replacing damaged wiring, correcting improper grounding, or installing arc fault circuit interrupters, also known as FSIs. Consider upgrading the electrical panel if it is outdated or insufficient to meet the home's current electrical demands. An upgraded panel can provide more capacity, improve safety, and accommodate modern appliances and electronics. Ensure that all electrical work is performed by licensed and insured electricians. This protects homeowners from liability in case of accidents or damages. Obtain the necessary permits for any electrical work performed. This ensures that the work meets local codes and standards. Keep detailed records of all electrical work, including permits, inspection reports, and receipts. This documentation can be valuable for future reference and for potential buyers when selling the home. Educate household members about electrical safety practices, such as avoiding overloading circuits, keeping electrical appliances away from water, and recognizing signs of electrical hazards. Periodically test smoke detectors and carbon monoxide detectors to ensure they are functioning properly. Replace batteries as needed. Install ground fault circuit interrupters, also known as GFCIs, in areas where water is present, such as bathrooms, kitchens, and outdoor locations. GFCIs protect against electrical shock. Consider surge protection to safeguard electronic devices from power surges. Surge protectors can be installed at the electrical panel or at individual outlets. Be aware of the potential hazards of aluminum wiring and take appropriate steps to mitigate the risks. This may include replacing the aluminum wiring with copper wiring or using approved repair methods. If you are unsure about any aspect of your electrical system, consult with a qualified electrician or electrical inspector. They can provide expert advice and guidance. Remember, electrical safety is an ongoing process. By staying informed and taking proactive measures, homeowners can help to protect their homes and families from electrical hazards.